Space. It's a vast and mysterious place. For centuries, humans have gazed up at the night sky, filled with wonder and questions. What's out there? How big is the universe? What are stars made of? These questions have fueled our curiosity for generations. Today, we're going to explore one of the most baffling mysteries of the cosmos, dark energy. Imagine the universe as a giant, expanding balloon. The galaxies we see are like dots on the surface. Now imagine something is causing the balloon to expand faster and faster. That something is dark energy. It's like an invisible force pushing everything apart. But here's the catch. We can't see it or touch it. We only know it exists because of its effects on the universe. It's like trying to understand a ghost. You can't see it, but you know something strange is happening. So, buckle up as we dive into the world of dark energy, a force so powerful it shapes the destiny of the entire universe. It's a tale of cosmic expansion, invisible forces, and the relentless pursuit of knowledge. For a long time, people believed the universe was static and unchanging. Then, in the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. By observing distant galaxies, he realized something astonishing. The universe was expanding. Hubble noticed that light from distant galaxies was stretched, shifting towards the red end of the spectrum. This redshift indicated that galaxies were moving away from us. The farther away a galaxy was, the faster it seemed to be receding. Imagine baking a loaf of raisin bread. As the bread bakes and expands, the raisins move farther apart. Similarly, the expansion of the universe causes galaxies to drift away from each other. This discovery revolutionized our understanding of the cosmos. The universe wasn't static, it was dynamic, evolving and growing bigger every second. But what was driving this expansion? The answer, as we would later discover, lay in the enigmatic realm of dark energy. The discovery of the universe's expansion was just the beginning of the mystery. Scientists expected the expansion to slow down over time due to gravity. After all, gravity pulls things together, right? However, in the late 1990s, two teams of astronomers studying distant supernova, exploding stars, made a shocking observation. The expansion of the universe wasn't slowing down, it was speeding up. This was completely unexpected. Something was counteracting gravity, pushing everything apart at an accelerating rate. That something was dubbed dark energy. It's estimated that dark energy makes up about 68% of the total energy density of the universe. Imagine a car rolling uphill. You'd expect it to slow down or even roll back down. But what if it started accelerating uphill? That's what's happening with the universe. Dark energy is like an invisible force pushing the accelerator, driving the expansion faster and faster. The discovery of dark energy sent shockwaves through the scientific community. It challenged our understanding of gravity and raised profound questions about the fate of the universe. The concept of dark energy wasn't entirely new. In fact, it had been considered decades earlier by none other than Albert Einstein himself. In 1917, when Einstein was developing his theory of general relativity, he introduced a term called the cosmological constant. At the time, Einstein believed the universe was static, neither expanding nor contracting. He added the cosmological constant to his equations to counteract the attractive force of gravity and keep the universe in balance. However, when Hubble discovered the universe's expansion, Einstein is said to have called the cosmological constant his biggest blunder. He abandoned the idea, believing it was unnecessary. Little did he know that his blunder would make a remarkable comeback decades later. The concept of the cosmological constant, once discarded, re-emerged as a possible explanation for dark energy. Today, the cosmological constant is one of the leading candidates for explaining dark energy. It represents a constant energy density that fills space uniformly, acting as a repulsive force that drives the accelerated expansion of the universe.